This is the generic flight collector group, and this is our week 6 update. This week we made a lot of progress on our tech demos. We finished up a draft for our section 2 of our project document. We finished up our direct impact analysis essays, and we also received the boards for our project from Collins Aerospace, so we can start working on those. This week in my tech demo, which is focused on making a computer program that can analyze basically live video and say what the objects are, I was able to get a connection through a network with a place where I can now go and measure fruits and vegetables. I need to collect a very high amount of data for my project, so over the following weeks I now have a place to go to measure and take pictures of hundreds of fruits and vegetables, which will be very useful for my tech demo.
Hi, for my tech demo I am choosing to do the Android app, the Android weather app, and the progress I've made on this since last week includes defining the inputs and outputs, what type of data is going to be presented to the user, and a couple other features such as choosing the location and what the user should wear depending on the day that they will be going out, as well as tabs for today, tomorrow, and the next 7 days. This type of layout will be helpful for the flight data collection project, as it will allow us to have the foundation of an app that would then present flight data for a video interface and other cabin info on either an Apple or Android device. Being able to make this progress means that we will have a better understanding of what to expect once we need to design our app for the design project and what to expect moving forward.
So for this week, for the individual demo, I look at the datasheet for the TPS 54232 non-synchronized back DC to DC converter. I look at the datasheet and think about how to calculate the resistor and the capacitor, and then what do I need to buy for the future. So I'm getting ready to design. And for our project document, we did the section 2 of the project document. So we have a couple requirements.
All right, so from what we know from our project, we currently have a few requirements set up, mainly just to ensure the operation of the project went smoothly, and also the project itself works as expected. We can see that we have a lot of requirements that mainly just to ensure the installation and reinstallation process went smoothly, but we also have the main operation of the system right here, and we also have protection in place to ensure the actual product will run smoothly. So we have our military standards and the IEE standard and IEC standard. Those include some aviation standards. So IEE 1156.1 includes a microcomputer standard for avionics. So all of these standards just ensure our product does not poses any hazard to the aircraft itself.
For the section 2, we also discuss about the rules for our project. So there are 6 rules of our project. I'm gonna be free to describe them. One of the rules is from behind schedule on attack, which is a high risk impact. The other risk is our product must be able to hook up to a helicopter, drone, or whatever we are testing on. That is also a high risk impact. Our product must be testable with our helicopter or drone powering it. There's a medium impact. And different assigned portion of the project are not operating as intended. That is also medium impact. The other risk is vendor delay. There is also medium impact. The last question is our product does not combine well within the team members. The risk is high risk.
Hi, this is Anthony, and for my tech demo, I'm going to go with the embedded system because it will be closely related to our project, which is using an embedded system based on NVIDIA Jackson platform. And we'll have an external interface for our project because we need high-speed connections, and we have to use FPGA because the microcontroller will never keep up with that. All right. So for my tech demo, I'm going to leverage it to solve some of the problem I have in real life. So I have multiple devices to connect to my desktop, and right now the multiple dongles extension hubs are not very helpful because they lack the power to power on all these devices. So the plan is to have a docking station that I can have with two USB-C connection to provide enough power. And we'll have to use a USB hub at controller IC because as I say, the microcontroller is too slow, not fast enough for high-speed connection. All right, so for our next step, we're going to update and prepare our developer kits, which is the NVIDIA Jackson platform that we just received. And also we're going to set up some development tools, mainly the GitHub repositories. And we're going to redesign our block diagram because as far as we know right now, we have a different block than what we are expecting. The development kit is not what we are expecting. So after that, we'll be doing the block diagram assignment, which is the section 3 for our project documentation, which is due sometime next week. All right, have a nice day.
Here's the time breakdown for this week. We spent about half an hour in a team meeting working on what to put in this video, and we spent most of our week working on the design impact assessment draft, which was mostly done last Friday.